Every home relies on water flowing quietly through pipes, but few of us realize how fragile that system can be. Leaks, sediment buildup, and chemical contaminants can turn ordinary water into a source of frustration, or worse. One determined homeowner decided to tackle these problems head-on by constructing a system that not only filters and purifies water, but also repairs minor pipe issues, using just a blue barrel, gravel, sand, activated charcoal, and basic household tools. But here's the question. Could a DIY setup like this really provide safe, drinkable water and reliable pipe repairs? Or is it a risk waiting to happen? Let me know what you think in the comments below. The first step involved selecting a food-grade 55-gallon barrel, thoroughly cleaned to eliminate any potential contaminants. Coarse gravel was layered at the bottom, followed by fine sand, and finally, a thick layer of activated charcoal. Each layer was carefully leveled to create an effective multi-stage filtration system. PVC pipes were fitted for inflow and outflow, complete with mesh screens to prevent blockages, while minor leaks in the home's existing pipes were repaired using epoxy and compression fittings. A 24-hour pressure test ensured that the system would not fail under normal household water pressure. Once the system was in place, the homeowner began a 14-day monitoring period. Daily water samples were tested for turbidity, pH, sediment content, and odor. Within 3 days, turbidity dropped by over 70%. By the end of the first week, the activated charcoal had significantly improved taste and eliminated chemical odors. The flow rate stabilized, and all repaired pipes held without any leaks. Throughout the process, attention to detail was critical. Barrel sanitation prevented bacterial contamination. Layering the filtration materials in precise measurements ensured proper water flow and maximum filtration efficiency. Flow calibration was adjusted carefully to mimic natural household water pressure, preventing strain on the system or the repaired pipes. Legally, DIY plumbing projects like this fall under specific guidelines. Using non-toxic materials and maintaining compliance with local potable water standards is essential. Connecting such a system to municipal water lines may require inspection or permits, and any permanent pipe repairs must comply with local plumbing codes. This information is provided for educational purposes only and does not constitute professional legal advice. Minor adjustments, such as the exact thickness of sand and charcoal layers and the angle of the inflow pipe, became key turning points. Small changes dramatically affected filtration efficiency and overall water clarity. Additionally, testing the repaired pipes under pressure prevented future leaks and ensured the system's reliability over time. By the end of the 2-week testing phase, the system demonstrated that it could consistently filter water, improve taste, and maintain minor pipe repairs. Daily maintenance, including checking flow rates and occasionally rinsing the top gravel layer, kept the system functioning optimally. Activated charcoal replacement every 6 months and periodic sand replacement were recommended for long-term effectiveness. The homeowner also documented the cost-effectiveness of the system. Compared to commercial water filters and professional plumbing repairs, the DIY setup provided a significant savings while delivering comparable results if proper materials and procedures were used. Given the results, do you think homeowners could safely implement such a system themselves, or is it better left to professionals? Share your thoughts in the comments below. As this system proved effective, it also highlighted how much control homeowners can have over water quality and minor plumbing issues when they understand the materials, flow dynamics, and safety requirements. After establishing the initial setup and confirming that water was flowing correctly through the system, the homeowner focused on long-term monitoring and testing. Each morning, water samples were collected from the outflow pipe and analyzed for clarity, chemical odor, and taste. Simple household tests, including visual sediment inspection and pH strips, were used to complement lab-based measurements, ensuring that the system consistently met basic potable water standards. Within the first week, sediment levels were noticeably lower, and water clarity improved with each passing day. The activated charcoal layer absorbed residual odors and chemicals, including chlorine traces common in municipal water. Meanwhile, minor leaks in repaired pipes were re-inspected daily. The epoxy and compression fittings held firm, demonstrating that even small repairs could maintain integrity when carefully installed. One critical observation emerged on day 5. The homeowner noticed a slight decrease in outflow pressure, which prompted adjustments in the inflow valve. By slightly raising the inflow pipe and realigning the gravel and sand layers, flow rate returned to normal, proving the importance of fine-tuning the system after installation. This step became a key turning point, ensuring consistent performance for the remainder of the testing period. Throughout the monitoring period, legal considerations were kept in mind. Even though the system was designed for personal use, the homeowner made sure all materials were food-grade and non-toxic, aligning with local health guidelines. Additionally, no direct connection to the municipal water system was made without inspection, preventing potential code violations. Homeowners considering similar setups should consult local plumbing codes before integrating any DIY filtration system into their primary water supply. The science behind the filtration process was straightforward but effective. Gravel removed large sediments, sand trapped smaller particles, and activated charcoal absorbed chemical contaminants and odors. The three-stage design created a continuous flow of cleaner, safer water. Monitoring the pH level confirmed that water remained within safe drinking ranges, and occasional taste tests demonstrated a noticeable improvement compared to untreated water. During week 2, the homeowner introduced a minor variation, reversing the flow direction for short periods to prevent channeling, a phenomenon where water takes a path of least resistance and bypasses portions of the filtration layers. This adjustment improved overall efficiency, further demonstrating the value of hands-on experimentation within safe parameters. Maintenance routines were established concurrently. Gravel and sand layers were checked for compaction, ensuring that water passed evenly through all layers. Activated charcoal was rinsed and replaced every few weeks during the testing phase to maintain adsorption effectiveness. Pipe connections were rechecked after each inspection to confirm that no slow leaks developed over time. By the end of the second week, turbidity had decreased by more than 80%. Chemical odors were largely eliminated, and minor repairs in the home's piping remained intact. Flow rate stabilized at a level consistent with typical household faucets, allowing for everyday use without interruption. The homeowner also compared results with commercially available water filters. Although larger professional systems may provide higher levels of purification, the DIY system proved sufficient for general household water needs, particularly for tasks such as cooking, drinking, and cleaning. The cost-effectiveness was striking. Materials for the DIY system were significantly cheaper than equivalent commercial units, while repairs and maintenance could be managed at home without professional intervention. This practical application raised a question about long-term sustainability. Could a DIY system like this function safely for months or even years without professional oversight? The homeowner's experiment suggested that with careful monitoring, scheduled maintenance, and adherence to safe materials, the system could operate effectively over extended periods. But here's the question. Would you trust a DIY water filtration and pipe repair system in your own home? Or would you rely solely on commercial solutions and professional plumbers? Share your thoughts in the comments below. As the system continued to operate into the third week, the homeowner focused on long-term reliability and efficiency. Daily inspections confirmed that the water remained clear and free of sediment. Minor adjustments were occasionally necessary to maintain flow, including slight repositioning of gravel layers and cleaning the mesh screens to prevent clogging. These small, hands-on interventions proved essential for maintaining consistent water quality. Chemical tests were conducted every few days to check for pH levels, chlorine content, and other contaminants. The activated charcoal layer consistently absorbed residual chemicals, keeping water taste and odor within acceptable standards. Sediment accumulation remained minimal, and the pipe repairs performed with epoxy and compression fittings showed no signs of leakage. The homeowner also implemented a scheduled maintenance routine, which became a critical factor in system performance. Gravel and sand layers were rinsed and replaced every few months, while the activated charcoal was swapped out every 6 months. Pipe connections were rechecked, and minor leaks were repaired immediately. Following this routine ensured the system continued to function efficiently over time without major failures. An additional experiment involved temporarily using slightly higher water pressure to test the durability of both the filtration system and the repaired pipes. The system successfully withstood these conditions without structural compromise, demonstrating that properly designed DIY setups could be resilient when built with care and correct materials. Legal compliance remained a top priority. The homeowner verified that all materials were non-toxic, food-grade, and safe for potable water, and no direct municipal connections were made without approval. This maintained adherence to local plumbing codes, which often regulate permanent modifications to household water systems. Even though the system was effective, these precautions underscored the importance of staying within legal and safety boundaries. Over the course of a month, water clarity, taste, and odor consistently improved compared to untreated sources. flow rates remained stable, and all repaired pipes maintained integrity. The combination of filtering, purifying, and minor pipe repair capabilities proved effective for daily household use, demonstrating that careful DIY efforts could complement professional plumbing work. The homeowner also documented the practical benefits: reduced reliance on bottled water, lower water waste, and cost savings compared to frequent professional repairs or commercial filtration systems. These benefits emphasize the potential for homeowners to take control of water quality while staying compliant with safety standards. Despite its effectiveness, the system also highlighted limitations. Continuous monitoring and maintenance were required, and complex plumbing issues still necessitated professional intervention. Additionally, connecting a DIY system directly to municipal water without inspection could result in legal or safety violations. Understanding these boundaries ensured that the system remained safe, efficient, and compliant. At the conclusion of the month-long observation, it became clear that a properly designed DIY water system can significantly improve household water quality, support minor pipe repairs, and provide an affordable alternative to commercial filtration systems, while remaining compliant with legal and safety standards. So here's the final question. Would you attempt a DIY system like this at your own home, or would you leave it to professional plumbers? Share your thoughts in the comments below. If you found this guide helpful and want to see more practical, verified DIY home solutions, make sure to subscribe to the channel, press the bell icon, and stay updated with our latest videos. Also, comment below and tell us what topic you want our next video to cover. Your suggestions help shape future content.